Hey, everybody. This is Larry. This is day 18 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Max number of k-sum pairs. So I usually read and try to solve these problems live and explain these live with my thought process. So definitely, if it's a little bit slow, just fast forward through it. Okay, cool. So you're given an integer array nums and an integer k. You can pick two numbers and you go to k and then we move them to array, return the maximum number of operations you can do on the array. Okay. So I think this is a little bit weird and a little bit tricky. The thing to notice about this problem, and this is something that you're going to have to play around with similar problems, and just if you do enough problems, you'll pick up on these things. And it seems like I know it but it's just from practice, right? And it is just that if there are two numbers that sums to k, you can do this in a greedy way, because if two numbers, like, if a plus b is equal to some number c, a plus another number cannot equal to c, right? So that means that there is a unique matching between a, b. If you have a plus b equals to c, there's a unique pairing of a plus b for a given target k, right? Or c or whatever. So knowing that, that's enough for us to do greedy. And as I said, these are things that, when you practice enough, you kind of notice these kind of, I wouldn't say pattern or trick or whatever, or just observations, and that, you're able to do that, in a quicker way. If not, then you have to convince yourself that this is true. You have to play around with the numbers to convince yourself this is true. But this is something that, if you've done enough problems, if you do your homework and you do enough practice, it is true. And because of that, it is easy to come up with greedy, because why is it greedy? Because the only unique pairings that you remove, so that means that there's no weird, there's no decision, right? The only decision is either you remove it or you don't, and because you want to remove them as much as possible, well, that's greedy, because it doesn't make sense to have a pair that you can remove and not remove, because you're not saving them for later. There's no decision, there's no choice. So yeah, that's basically the idea. And there are a lot of different ways to implement this. I think you could probably do some sorting. You could sort and then do a 2-pointer walk. That's going to be n log n because of the sorting. If it's already ordered, then you can do it in linear time. But I'm going to put in a hash table, which let's just say it is constant thing, though I know that is a little bit more nuanced than that, so that may be a little bit tricky. But yeah, so I'm going to just, in the hash table, you can have something like, let's just, table is equal to hash table for, x is nums, table is something like that, right? So you can definitely do something like that. In Python, there's actually a little trick, so I'm going to do it that way. But know that, so this actually puts everything in there for you, kind of like this code. I mean, I'm just showing you, but and in a contest, that's what I would do, and this is what I would do, right? But definitely on an interview, just probably be safe and put in a for loop, because then now you have to explain what a counter does, and you don't save time if you have to explain it anyway. Okay. And then now we want to find out the number k, so then we just have to do it in a greedy way. You could kind of, you could do it however you like. I'm just going to go key by key in a weird way, probably, but it is just as easy as it goes. So for, I was going to write a again, k, but for a in table.keys, so basically what we want to do is we want to find b, right? So b is equal to k minus a, as we talk about, because we want to do a plus b is equal to k. So then, okay. And then the answer that we get from, let's have a count. Just this is the answer that we're returning. We return count in the end. And then the number of count, we could do it one by one, but the idea is that, if you have multiple pairs, then in a greedy way, you just take the min of those the two keys, right? There is one exception which we'll go over in a second. Right? If you already thought about that, then congrats, you're ahead of me. But oh yeah, so count, we just, it goes to the min of this. We're gonna double count if because A and B both appears in table, so so we just have to do something. We could do it in one or two ways. We can either we can manipulate the table to like we could keep track of pair as you go to this, pair, table B and pair, right? And that should be good. You could also just do another way of like, if A is greater than B or something like that, then you continue, because that means that we've already done it, or something like that. There are different ways of doing it. Then the trick case, of course, is if K is even, then you may have duplicate numbers, right? Like for example, I think it's even in one of the cases. Yeah, if this is 6, then you could have 2 3s. So we just have to keep track of that. So if A is equal to B, then, and that means that it would only appear once anyway. So then we do something like pair is equal to table of A mod 2, or divided by 2, sorry, and then we do else this. That's weird. And yeah, and so this should roughly be right. I hope so. If not, then I look like an idiot, but that's fine. But yeah, now I'm just copying and pasting the test case and hoping that I don't have a typo or anything. But oh yeah, diction. Okay, so that was one thing that I worried about, and the short reason is because using counters that whatever, this may actually create a table thing. So we can just actually just get the keys manually, which is fine, and then just iterate through it. Oh, because this is still an iterator. Now we've converted it to a list so that we don't change that iterator as we go. Yeah, looks good. Let's give it a submit. Hopefully I don't have a weird edge case. Okay, cool. Yeah, so what is the complexity of this? Well, we use a hash table, and then for each of those key in the hash table, which in the worst case you could have n keys for a list of size n. So it's going to be linear times. This is all constant cost. So given the n keys, it's going to be linear time. And in terms of space, again, because you have a hash table with n elements, that's going to be all of n space. So linear time, linear space. That's all I have for this problem. I think it's kind of straightforward once you practice the problems enough. I think the hardest part is probably just coming up with the convincing yourself that greedy is correct. And I say this a lot on some of my other videos or whatever, which is that with practice you are able to kind of get better at greedy type problems because you have already proved these in the past. Like this A plus B K thing, like you may you're not familiar with it, if you didn't practice it earlier, you might spend like 10 minutes like proving to yourself that's correct, and that's okay, because I probably have done it in the past, and it's just that when you've done it a few times, you remember it a little bit, and you're just like, okay, I know this to be true because I proved it a few times, right? So anyway, yeah, that's all I have. Let me know what you think about this problem. I will see you tomorrow. Bye bye.